Have you ever stopped to think about how a self-driving car actually sees a pedestrian? Or how your phone can pick out a face in a crowd of photos almost instantly? Well, that's exactly what we're doing. We're teaching machines how to see. And today, we're digging into the story of YOLOv8, one of the most powerful tools making it all happen. Okay, so let's start with the big question. For us, seeing is second nature, right? We just do it. Before a computer, a picture is just a giant grid of pixels, a huge jumble of numbers. The real challenge, the fundamental problem for AI, is turning all that raw data into something it can actually understand.
And that challenge has a name: object detection. It's not enough for an AI to say, hey, that's a picture of a busy street. Nope, it has to find the car, the cyclist, the stop sign, and then draw a super precise box around each one. It's all about recognizing what is there and exactly where it is.
Now, for a long time, this was a really slow, step-by-step process. But then, a total game changer came along. You only look once, or as it's famously known, YOLO. Instead of looking at an image over and over again, YOLO treats the whole thing as one single problem. It figures out what the object is and where it's located all at the same time. This makes it ridiculously fast and efficient.
So here's our game plan for this explainer. We're going to cover the quest for AI vision, get to know the latest version, YOLOv8, break down how it actually works, check out its performance, and then, most importantly, talk about why any of this really matters. All right, with the stage set, let's kick off our quest for AI vision. This is a story that moves at an incredible speed, and it's taking us right to the bleeding edge of what's possible today. And the star of our show is YOLOv8. It was released in 2023 by a company called YOLOv8, and it's the newest, most polished model in this whole groundbreaking series, building on the legacy of its predecessors. And what's really wild is just how fast this thing evolved. I mean, it wasn't just released and then forgotten. Within just a few months, boom, it got a new anchor-free design, which is a much smarter way of finding objects. Then it got powerful tools for developers, a beefed-up backbone for better feature spotting, and support for running on all kinds of different hardware. This thing is a living, breathing project. All right, now for the fun part. How does YOLOv8 actually see? Don't worry, we're going to make this super clear. Let's pop the hood and take a look. Its design has three main parts. First up is the backbone. You can think of this like the retina of your eye. It's a deep neural network that scans the pixels and pulls out all the important features, things like edges, colors, and textures. Then you have the neck, which is brilliant. It combines those features, mixing the big picture stuff with the tiny details so it can understand objects whether they're huge or super small. And finally, the head acts like the brain, taking all that info and making the final call. That's a dog, and it's right there.
Now, one of the biggest innovations here is that it's anchor-free. See, older models used a bunch of preset box shapes, these anchors, and tried to fit them onto objects. It was kind of clunky. YOLOv8 is way smarter. It predicts the center of an object directly, which makes it way better at finding things with weird shapes and just makes the whole training process a lot simpler.
And it's not just a smarter design. It's trained in a smarter way, too. It uses some cool tricks like data augmentation, where it basically creates new training images by digitally cutting and pasting other ones together. It also uses something called focal loss, which is like a coach telling the AI, hey, you keep messing this part up, let's focus here. Plus, it uses mixed precision training to learn way faster and use less computer memory.
So that all sounds great in theory, right? But does it actually perform any better? Well, let's look at the data and see the proof for ourselves.
And wow, this table says it all. Compared to the previous version, YOLOv5, YOLOv8 isn't just a little better, it's a clean sweep. It's way more accurate, that's what MAP measures. It's the gold standard for object detection, and higher is always better. It's also faster, it takes less time to train, and the final model is even smaller. It's a win-win-win-win.
But here's the thing. The team at YOLOv8 knew that one size definitely does not fit all. I mean, the AI you need for a giant server farm is totally different from what you'd run on a tiny security camera. So YOLOv8 isn't just one model, it's actually a whole family of them.
And here's the family portrait. It starts with YOLOv8N, the nano model. It's tiny, it's lightning fast, perfect for small devices. And it scales all the way up to YOLOv8X, the extra large version. That one is an absolute beast, giving you the best possible accuracy for things where you just can't be wrong, like analyzing medical scans. This chart really drives that point home.
As you move from the smallest, nano model, to the biggest extra-large one, you get this huge jump in accuracy. But look at the speed. Yeah, it gets a little slower, but the difference is nowhere near as dramatic. This gives developers this incredible flexibility to find the absolute perfect sweet spot between speed and power for whatever they're building.
So we have an AI model. It's faster, more accurate, and way more flexible for seeing the world. Okay, great. But what does that actually mean for us in the real world? Why does any of this matter? It matters because this tech is officially leaving the research lab and showing up in our daily lives. It's what makes smart devices smart, without needing to be connected to the cloud 24/7. It's a key piece of the puzzle for making self-driving cars safer. It's helping doctors spot diseases earlier and letting factories automate their quality checks. It's even powering new features in the apps you use every day on your phone.
And maybe the most crucial part is that YOLO8 is built to be used. This isn't just some theoretical paper. It comes with a simple Python package and works perfectly with popular tools that developers already love. This lowers the barrier to entry, so more people, more companies can start building the next generation of smart apps.
You know, the source material we're looking at really sums it up perfectly with this quote. YOLOv8 isn't just for academics in a lab, it's a powerful, ready-to-go tool for both cutting-edge research and real-world industry. It bridges that gap just beautifully.
We've seen how it works, we've seen why it's so good, so now let's just pull back for a second and look at the really big picture here. What does all this progress really mean? Models like YOLOv8 are a massive leap forward in giving machines a true sense of sight. They're getting faster, they're getting more accurate, and they're getting easier to use every single year. So the real question it leaves us with is this. As this incredible technology keeps getting better and better, what currently unimaginable possibilities are we going to unlock tomorrow?